So we're going to do this kind of basic string compression problem. This introduces a very popular pattern in algorithms called two pointers. There's different ways we could do this problem, but two pointers is a traditional way to do it and a good thing to learn. So you've got the URL there. You're going to go to train. You can pick your language and go to train. All right. We're just going to try and follow the exact same process, and it's the same. So first, read aloud. Basic compression. First, you will write a very basic compression algorithm. It gets a string, and here's an example, a bunch of A's and a B and then some more A's, and generates an array that sums all the repeating characters like so. So we have an array of arrays. Each subarray or internal array has two elements, a count, which is an integer, and the character. So we have 8 A's. I presume this is 8 A's here, and then 1 B, and then 4 A's to finish it off. Great. The compressed version is turned into a string. So this whole array of arrays is then turned itself into a string. I just posted it in the chat. You're asking for the link. You should see it right above your comment, and now I've just reposted it. Okay, finally, if the compressed version is shorter than the original string, the function will return the compressed version. Otherwise, it will return the original string. So here we have an example of a bunch of A's, and then a B, and then a bunch more A's. And so we see 26A, 1B, 18A, which is clearly shorter than this whole string here. So this would be the correct answer. Example 2, we see A, B, C, D, and E. And if we were to compress it, so to speak, right, we would have 1A, 1B, 1C, 1D, 1E with all the different brackets around it. And that, I presume, from what it's showing us here, would be longer. Of course, it makes sense than the string itself. So we just return the string. After you created the compression algorithm, create the decompression algorithm. It gets a string, output 1, output 2, etc. If the string is compressed, it returns the uncompressed version. If it is uncompressed, it returns the original string unchanged. So output 1 is basically a matrix, but it's all turned into a string. And then we run uncompress on it, and we get all of those A's, so 26 A's, and then 1 B, and then 18 A's. Okay, and then output 2, we send in A, B, C, D, E, and it just returns A, B, C, D, E. So it has no brackets, and so it's just some letters, and we're going to return it. Note, the original string may not contain the opening bracket or the closing bracket for obvious reasons. You are always welcome to check out some of my other katas. Perfectly fine. Maybe we will sometime. Thank you, Michael Sell. All right, so again, I'm going to work on putting this in my own words. Even if I'm alone and I'm practicing, I'm going to do this. If I'm with a friend, I'm going to do this. If I can get a family member to listen to me, I'm going to do this. Then I would say something like, all right, so this problem has two parts. Let me talk about the first part. The first part is we're going to be given a string of characters. It only shows lowercase characters. It might be other things. And here's where the process might mix a little bit, right? I'm starting to describe it, but I stumble on a clarifying question. And I think it's okay to say, so let me ask a clarifying question, actually. Will I only get lowercase characters here? Could I also get uppercase characters? Yeah, you could. Okay, could I also get numbers? Like, could I have 1, 1, 1, 1, 1, 1, 1, so that I would have, like, I don't know, 4, 1 or something like that in the compression? I presume they'd say yes. Let's imagine they say yes. It's the importance is asking the question, right? Whatever they tell us, we just roll with it. Okay, could I get punctuation? So I know I can't get an opening or a closing bracket, but can I get commas and the @ sign and things like that? Again, let's assume they say yes, you can. Okay, good to know. All right, so back to my description. We're given a string that could include really any character except for an opening bracket and a closing bracket. What we want to do is go through that string, counting consecutive similar characters and saving those to what I might think of as a tuple or an array with two elements, oftentimes called a tuple. The first part of that array is the count of the character, and the second is the character itself. Then we want to take each one of those tuples and put it in a sort of parent array. And finally, with that parent array, we want to convert the whole thing into a string. Then just ask them, did I miss anything? Does my description resonate with you? Does that sound like also what you understood? However you want to phrase that. It's just We just want to solicit their input, their feedback there. Yeah, Jordan, that sounds right. Or well, you talked about the tuple, but did you talk about putting it in a total array that holds everything? You know what? I think I mentioned that, but you're right. Let's just make sure. So each tuple goes into a array, and that array will have subarrays. Each subarray, again, has the count of the character and then the character itself. Yeah, Jordan, that sounds right. Okay, cool. And we're just going to do that until we both agree. If it takes us a minute, it takes us a minute. All right. Now the second part, and I'm going to tackle the first part first, but the second part is the second function could take in that compressed, like matrix string, I might call it. It was a matrix, but we turned it into a string, or it might take a string. Oh, you know what? I realized I missed something up here. I missed the part where if the compressed string is actually longer, then I want to just return the original string. Yep, that's right. Okay, great. And again, that might be the kind of thing the interviewer says, oh, did you consider the case where the compressed string is longer? Oh, you know what? I didn't. I read that and I need to do this with it. Great. So in the case we want to decompress, we either want to take that matrix string and take it back to just a pure character string, or we want to recognize that it's not a compressed string and you just want to return that string. Cool, cool. And again, anything they might want to weigh in on? Yeah, Jordan, that sounds good. I didn't quite understand. Can you reiterate it again? Whatever. And again, like, I just assume I'm not going to be able to get a job until I can adequately explain things to my interviewer, or at least it's not that likely. So if I struggle here, even if it's in a real interview, I just have to accept, like, hey, that's where I am. I need more practice on this part of the step. There's not, to me, there's not a compelling, oh, well, I should just skip this step if I'm not good at it. Like, no, I don't think so. I think you should just practice and get good at it. And if you blow it in an interview, then you just be easy on yourself and say, hey, I'm learning, I'm working, I got this good process I'm working with, and I got to get some friends around me who will listen to me explain problems and play them back for them until I can say it as concisely and clearly as possible. And I see so many people struggle with this. So if you feel like you struggle with it, then again, it's just something got to practice more. Okay. Then what do? We go to examples. Any clarifying questions? But I think I kind of covered my clarifying question, which was, could I get these non-lowercase characters? And let's assume, yes, we can get everything except for an opening parenthesis and a closing parenthesis. Okay, now I'm just gonna, not just gonna jump in, I'm gonna tell the interviewer again. All right, I'm gonna put together some examples here for the compress function. And it's gonna take me a minute here, but I wanna make sure I fully understand the problem. So we're getting a string. So of course, the simplest input would be an empty string. And if I got an empty string, like the compression could look like an array, and then inside of that array, another array, and then like 0 and an empty string or something like that. But of course, that's ridiculous. The answer here would clearly just be an empty string. And it's almost, I'm not even sure I'm going to check in on that one. It's such a simple case. We might just move on. All right. Now, next would be like a string with one character. So here, the compressed version would be something like an array, and inside of that, there's another array, and then there's 1 and then an A. But it doesn't take much to just count and see that this is about 8 characters. And again, that answer is just going to be A. Am I understanding that correctly? Yeah, that looks right, Jordan. Okay. All right, so they have an example kind of like A, B, C, D, E, however it is. Let's just go with A, B, C. So again, the compressed version here would be an array, and then inside of that is another array, and then in here we have 1A and so on and so forth. But just like their example down here, it's pretty clear quickly that this also would just be A, B, C. Great. Okay, now let's think about a case like this, A. Now this is a bit more unclear to me. So I would have an array, and then inside of that I would have an array, and then inside of that I would have a count, which is 3. And then I would have another thing, which is A. And then all of that would be a string. So again, it looks like I'm pretty much in a case where that's going to be much longer, right? I see I already have 3 characters right here, and I'm not even halfway through. So this also would just be A. Am I understanding that right? Yep, that looks right. Okay, cool. All right. So I'm not exactly sure where to go from here, but if I had something like A, B, then now I have my parent array, and then I have two subarrays, and each subarray has a count, which is 3, and a character, which is A, and then another count, which is 3, and another character, which is B. But again, if I count here, 1, 2, 3, 4, 5, or this doesn't count. 1, 2, 3, 4, 5, 6, 7. Yeah, I'm already past where I should be. So again, I'm at like A, B, B, B. Okay. Now we're like, what, 5 examples in, and we haven't even got to a truncated one yet. But as far as I'm concerned, all is good. If we want to go back and say, you know what, I over-exampled this, let's take out some of these examples, or I think these are testing the same thing, fair enough. But as far as I'm concerned, we're just doing a good exploration of the problem here. And again, if the interviewer is like, hey, we need to pick up the pace, okay, well then, all right, let me get to a couple more examples. But again, 9 times out of 10 or more, the interviewer is going to be like, yeah, okay, yep, that's right, that looks right. And they're going to be going along with you, and they're going to be saying, okay, we're rocking and rolling here. We're figuring out the problem. We're laying down a lot of cases. We're eliminating ambiguity, which is a huge, huge part of the job of a software developer, eliminating ambiguity. And most managers, hiring managers, are going to be so happy to see somebody who is training themselves on eliminating ambiguity. Okay, so now I want to make sure I can get to a case, of course, that we truncate. So if I were to do like 1, 2, 3, 4, 5, 6 A's, and now here I've got my leading array, and then my inner array, and my count of 6, and my A, and that would be 1, 2, 3, 4, 5, 6, 7, 8. Now, am I right? I would ask the interviewer, am I right to count these inner strings here? Because I'm going to have to cover this whole thing, or wrap this whole thing in outer strings like that. So even this looks longer than this here. And I, again, presume the interviewer is going to say, yeah, you're right. It would still just be 6 A's. Okay, I'm going to change this example then, because this is getting kind of redundant. I think we are exploring this pretty well. So I'm just going to go ahead and add some more. So if I add like 1, 2, 3, 4 more, now that's 10 A's. And now I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that would create a case where the truncated version is equally long to the string itself. Now that actually makes me wonder, I didn't ask this, but which should we favor in this case? When they're tied, should I favor the truncated version or the string itself? I hope your brain is like kind of exploding on this. I hope, right? You should be saying like, what the, I have clean language. I'm not going to cuss. What the heck? Are there, like, there's so much to explore here. Yeah, there is. There's a lot. And we're not even that complicated of a problem. So there's a lot of things to eliminate, lay down, make sure we understand, and pull out from the interviewer, especially in a world where we're not on a platform, and the interviewer is going to be the ultimate arbiter of how good our solution is. So then the interviewer would say, oh, yeah, in that case, you prefer the truncated version. Did the description say if it's tied? I don't think they say one way or the other. If the string is compressed, it return. Oh, no, that's not what I want. Where is it? Here we go. If the compressed version is shorter than the original string, the function will return the compressed version. Okay, so we should favor actually the string here, because the compressed version is not shorter, it is longer. Now, I think that's a valid case where it's tied, and I might even make a comment here. Something like, just to make sure that I have this right, we say this is a tied length case, something like that. So I can remember why was this case important as opposed to just this case here? Why is 10 A's specifically important? All right, finally then, I'm going to say I want this case, but I'm going to add one more A to it. That's 11 A's, and that then should give us our first truncated version. So that's an array with an array inside, with a count of 11, with a character of A, all wrapped in strings. Whoops, let me, come on, there we go. All wrapped in strings like so. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here is 11. So this is the truncated version that we're looking for. Great. Okay. From there, I think we've got these cases pretty well fleshed out. Are there any other weird cases I need to think of? I don't think so. So let me take some of the examples given. So here, and there's nothing wrong with working in the examples you're given at an appropriate time. And now is about the appropriate time to work in this example. we've got to our first truncated example. And so here we're going to do this. What does that look like? It looks like this. I'm just going to copy that and put it right here. Great. And then what else? This is the same. This case, I don't think I need to bring over. I think we've explored cases very similar to this enough to not include it. Isn't there one more up here? Yes. Here, this one. Let's grab this one too. And let's actually drop this one in right here. I could just tell the interviewer, oh, I'm going to put this one here because it's actually a little bit of a simpler case in that it's shorter than this one here. Though I can see it's longer than even my 10 case. So that goes here, and the result is this. Specifically, it's this as a string. I'm going to put that there. All right. I'm pretty good here. Do you see anything that I'm missing? Do you see any cases that I'm overlooking? And again, if you put in this work, if you've trained yourself to do this and put in this work, the interviewer is going to be very primed to help you out. The interviewer is going to be like, oh, how about this? What about this? Probably the interviewer has asked this question 10 times, right? They probably use the same question multiple times over months of interviews. And so the interviewer knows the ins and outs of this problem, even though you're likely seeing it for the first time. They have information they can share if you're missing it most of the time. And if you follow a thorough process like this, they probably will share with you. But let's just, again, if anyone sees anything, please yell it out or put it in the chat. I don't see anything readily that pops out to me. I think we're in a pretty good place here. And we can say we're done with our examples. So you say, okay, I'm feeling good about my examples here. These are going to be the basis for the tests that I write later. You can forecast that for the interviewer. At this point, I'm going to move on to my pseudocode. So again, if you didn't have this already provided, it would be our time to write this up here even before we write our pseudocode. But given that we do, let's jump into our pseudocode. All right. I'm going to just develop a pretty simple process here. And what I'm going to do is I'm going to say, create a pointer set to 0. So that's going to be my lagging indicator of where I start seeing a new character. And then I'm going to iterate over every character in string. And again, immediately I drop down. We don't need to add anything else to this line. That just means we're going to write a loop, in other words. And I'm going to say, is current character same as character at pointer index? Now, even this line, I'm thinking, can I get this shorter? Let me open this window a little bit. I think I can. I would tell the interviewer, let's see. What I really want to know is it different? So if I said, if current character not equal to character at pointer, and I'm going to go ahead and replace that. So if they're not the same, that would be like, and I would show the interviewer here. So my pointer would be here. And then my iteration, whether it starts here or later, it would go until it got to B. And now the character at I, so to speak, is not the same as a character at A. So I've got my 2 pointers and they're pointing to something different. That is what I'm doing inside of here. If that's the case, now I want to, what can we say here? Create an array. And then I want to push I minus pointer into array. And if we want to stop and sketch that for a second, we say, okay, I right here is 0, 1, 2, 3, and pointer is 0. So 3 minus 0 is 3, and that represents the number of A's that I see. So push I, 3, minus pointer, 0, into array. That would push a 3 into the array. And then I want to push the character at at pointer into the array. Now in example here, the pointer is pointing at A, so we would push A into the array. So that would look like an array with 3, comma, A inside of it. Finally, I want to push that array into compressed array. Now that makes me think I need to create a variable for that. I don't think there's any shame in this, right? If you get to a place in your pseudocode and you're like, oh, should have created a variable up here, no problem. We just go back here and we say create array to hold compressed tuples. You know, compressed tuples, compressed subarrays, whatever you want to call it. Again, a tuple is just the name of an array with only two, no more than two, no less than two elements, which is what these are. So push that array into the compressed array. Perfect. All right, now, next thing I need to do when that's all done, oh, you know what? We've got one more thing here, which is that we need to make sure that when we're finally done with our I, that we don't leave that pointer sort of trailing. We need to look at what's back there. The way I'm going to handle this actually when I write my loop is I'm going to take I1 past the end of the array, and then I'm going to add it like that. And I'm comfortable writing that when I get to the code. So again, that if I say something like that and Nimmer's like, no, I need you to put that in the pseudocode, they probably won't. They'll probably say, oh yeah, that makes sense. Okay, we'll get back to that. But if they do, okay, I need to put that in the pseudocode right away if that's what they say, but they'll probably say, oh yeah, that makes sense. Okay, fine. All right. So then here, I need to turn compressed array into a string. And finally, return the shorter of compressed array as a string and string. And that should give me my expected answer. And we might talk about efficiency here. I might say there might be a more efficient way to eliminate some of those early examples to just not even worry about iterating over them. But I'm just going to go ahead and iterate over everything to begin with. And then if we have time, we can look for some extra efficiencies here. Great, Jordan, sounds good. Or again, the interviewer might say, no, let's explore those efficiencies right now. Okay, again, they probably won't, but if they do, okay, yeah, let's do it right. Okay, let's do it right now. Okay, at that point, again, we're going to check in. This is my idea for my process here with my pseudocode. Do you see anything I'm missing? Does this make sense to you? However you want to phrase that. Again, just checking in with the interviewer. Yeah, Jordan, that looks like a reasonable approach to this problem. Or it's not clear to me what you're doing here on line 9 or whatever. Great. Whatever they say, we just go with it. Oh, good point. Maybe that's not clear or whatever. I'm not going to try and make up something like that here, but if it happens, you just stop and say, you know what, maybe the way I phrased that wasn't clear. Let me think that back. Let me go back through that. Let me put it to you a different way. Would it make more, can you see a better way for me to rewrite that? Again, it's fine to ask for help there. Not like, what do I do now? That's not okay. What should I do here? Probably not okay. How could I make this more clear? Or do you think I could clear this? Do you see some language that would help clear this up? Something like that. Perfectly fine. All right. With that, then, we're ready to go to our examples. So let's minimize this window. Let's clean up just a little bit here. I'm going to get rid of these pointers so they don't get in our way. We're going to leave this guy here for now. And let's open up our tests. And one of the reasons I love CodeWars, if you've ever been in class with me before, of course, you've seen me do this. It's so awesome to be able to write tests in a way like this. It's such good training for you. We're going to clear up this a little bit so we can get ready to write some tests here. And I'm not going to spend a ton of time on this. You can explore this a little bit more, but we're going to do here, even this, I'm going to just comment out all of those things. Okay, first thing we want to describe, what are we actually doing here? Truncate string as array of tuples. That's not like the right answer, right? But the right answer is something that you fit on one line that's fairly concise that describes what you're doing. Then inside we set up our it block, and I just left this one here from the ones that were already here. And we're going to say something about our test cases. So our first case is it handles an empty string. With that, I shouldn't have deleted these. We want test dot assert deep equals. No, assert equal. I don't know this syntax super well. And now we're kind of back to the exact same place we were. First thing we want to do is we want to put in the function that we're going to run. That's compress. So here I'm going to write in compress. We want to pass in our first example. That's an empty string. This one I'm just going to type out. Then we want to put a comma. Here we don't use 3 equal signs. We just put a comma, and the test itself will tell us what we're expecting here. And with that, we'll go ahead and run it. And hopefully we see test.assert equal. How about assert equals? Let me just fix my context. There we go. So I've got my name was wrong here. It's assert equals, not equal. And this is just a regular plain old failing test. You told us to expect an empty string. Instead, we got undefined. Great. Now we can get to our code here. So here's a string. We don't need to do all of this right now. We could do something like, how about I bring in compressed array? So here I'm going to say let compressed array equals an empty array. And then down here, I'm going to write return. Oh, you know what? We're going to have to turn it into a string. So how about we do let compressed string equals compressed array dot to string, like that. This again, this is an example. This should be the easy part for you. How to turn an array into a string. That's the kind of thing that you need to be practicing enough till you're like, yeah, I know how to do that. You know, if something like one of these things, you got to Google, you got to ask the interviewer, can you help me out here? I'm not totally sure what syntax to use. You know, 1 or 2 things in the context of a problem I don't think is a big deal, but we can't be needing to constantly look up how do we split, how do we sort, how do we rearrange and reverse and all those things. You need to have those things down. Okay, so then I want to say I want to return. So if compressed string dot length is less than string dot length, and even this we say if it is less than or equal to, then I want to return string. Otherwise, I want to return compressed string. So here our array should be empty. Our array should be, I'm sorry, 2 characters, and our string should be empty, which should give us our array. Let's see if that works. Something did not work. What's going on here? Unexpected token. Okay. Oh, my bad here. This needs to be a question mark for a ternary statement in JavaScript. You're familiar with that. Okay, compressed string is not defined. Yep, and sure, this is again where I should have just copied and pasted like that great developer told me to, and not try and retype it. And there we go. That is passing that test. With that, we're ready to move on to our next test. And we go ahead here and we look at our examples. So here we say, maybe we can group these together. Let's see if we can. So what if we say it handles a string of 3 or less characters? I think these are similar enough to be grouped together. And now we can just start putting in A should be A. Let's give that a test. Okay, that is working fine. And I'm not going to trouble myself too much as I do this kind of test-driven development. If it works, it works. If we break it later, we break it later. We'll figure it out. ABC should be ABC. Okay, that works. I'm a little bit concerned about why that works. I think maybe we should look into that. Why is compressed string dot length less than this? Shouldn't this be 2 characters and this is 3 characters? Let's just stop ourselves here and say, you know what? Time to do a console log. Let's console log compressed string to at least get some clarity here and see what we're getting here. We open this up. I don't actually see it. Console logging, why not? But if I get rid of my return statement for a second, what did I do here to not get a console log going? I don't know. Test error expected this got undefined. Got undefined. Yeah, that I see that. If I intentionally break this test, will I see the console log? No. I still won't. Okay, I don't know why we're not getting the console log here. That's a little bit confusing. But okay, we'll roll with it. Let's one thing we could do, of course, is we could take all of this and bring it over here. I'm just going to run this down below. So let me comment out all of that and take a look here and say, okay, I want to run compressed array to string, compressed string. Yeah, looks good. I want to run compress. I want to pass in what I was just testing, which is ABC. And I'm looking to see this console log. So let's give it a run and see what we get. Absolutely nothing. So there is an empty line here. So this is just coming out as nothing. That is something we got to stop and figure out now. Why is it? Let's take this up one level. Let's go here and let's look at our array. Got it. So here's some limits of my JavaScript knowledge, right? When I take an array and I call toString on it, I actually get an empty string. It does not include the brackets on the outside for that string. Even if I were to put something inside of it, I'm guessing, I still don't get those brackets as part of the string. So we can fix that. We say, okay, so actually what I need here is like an interpolated string with an opening bracket, then this as a variable, then a closing bracket, and then this. And now let's give that a run. Okay, I see the array here, but that is not really what I'm looking for. I need to move back down here. I need to check my string, and I need to go again. That looks better. Now, finally, we can go ahead. Great. With that, I think we're fine. I'm just going to copy this one line, bring it over. Sorry, wrong page. Here we go. And we will replace this here. Good. I'm going to keep this console log here. Let's see if I think I was just missing it because it didn't have anything. Yeah, good. Here we go. Now we're getting broken tests. Expected an empty string, instead got this. Looks like we've gone ahead and broken our first test here. Yeah, looks like it. When that happens, no problem. I'm just going to go ahead and comment these out. I'm going to say, I think I broke my first test. I'm just going to go back and fix that. Let me run that again. Yeah, it's broken. Expecting an empty string, instead got this. Let me check my logic. Compressed string.length would be 2, I think. 2 is less than an empty string.length. I'm sorry, is more than. So is this less than? No. Therefore, return this. Looks like I got my order messed up here. Let me try that again. So maybe I'm supposed to be like this, and I just messed up my logic. That looks better. Cool. So no problem, right? We might lose a job for that. Someone could say, oh, they don't know it well enough. Oh, they messed it up. Oh, they didn't know toString well enough. What are you going to do, right? Just practice more on CodeTrack. That's all we can do. Otherwise, we just got to stop. We got to go through it. We got to figure it out. If we lose, we lose. No big deal. Okay, great. With that, I'll bring in my tests again. I'm going to go one by one here. So I'm going to bring in this it block and then this test here and run that. Okay, that looks good. Now I'm going to bring in this one. Now this one, I expect it to fail because this array string actually should be shorter than this. Boom, failing. Okay, we got to fix that. We should be getting ABC here. Instead, we're getting this empty array. We're going to have to do more coding. So what am I going to do? I'm going to start bringing in some of this code here. First thing, create a pointer. Let pointer. It's 9, guys. I think we're going to be another 12 minutes is my guess. I hope you can hang out. Of course, the recording will keep going. If you can't, you can watch the recording. We'll get our pointer, set it to 0. We're going to go over every character. So let's do for let I equals 0. I is less than or equal to string.length. We'll get to why I'm using less than or equal to later. I++, and immediately I bring that down. However you want to do it. You want to highlight this and move it in. You want to copy that and bring it down. Just make sure you get this encompassing everything that's going to go inside of it. Okay, here we say if, and again, our hard work is done, so writing our code should be fairly quick. If string at I is not the same as string at pointer, then again, I do the same thing. I open my brackets and I wrap them right away. And we'll go ahead and, I guess it's fine. We don't need to move that in further. Something's not lining up here. That, okay, that looks good. Okay, create an array, fine. Let tuple equals this array here. Push I minus pointer into the array. Tuple dot push I minus pointer. My pseudocode is my boss, right? It's telling me exactly what to do. Push character at pointer into the array. Tuple dot push string at pointer into the array. Okay. Push that array into the compressed array. Okay, so that's compressed array. Let me take my advice here. Dot push tuple. Okay, then we're gonna have to see if this is actually gonna work the way we want it to. Now that I'm seeing like, kind of reached the limits of my knowledge on array to string, might have to check that out. But let's see where we're at so far. Run that. Hey, that worked. Now, as a double check, I want to see what that compressed array looks like at the end. So I'm going to just do console.log compressed string. And I would just tell the interviewer, I don't know this method to array to string very well. So I want to check what I'm actually getting here before I move on. If I open this, okay, here we go. I'm getting 1A, 2A, 3A. So this is good and it gives the right answer, but it actually does not satisfy the problem. This is not what it should look like, since I should have in here arrays wrapped around each one of these. I'm going to have to work on that. I think I'll do that now. It's a good time to make sure we get that right. So here with compressed string, it's not enough to sort of compress each one of these. I think what I'm going to do is actually add some more pseudocode here. I'm going to say iterate through each tuple in compressed array. And with each of those, I'm going to convert them into a string. Yeah, okay, that'll work. Then I'm going to do this here. So let me stop and do that, and then we'll get to here. Okay, great. I'm going to leave this console log here because I want to make sure I'm doing this right as I go. All right, so here I want to say something like for let I equal 0. I is less than compressed array. Let me just copy that. Make our code bigger here. I is less than compressed array dot length I plus plus. And we'll bring that down. Okay, now each tuple looks like, why are we subtracting I minus pointer? So I gave the example here when I was writing out the pseudocode. Pointer, in this case, would start at 0. We'll call that line pointer. And I also starts at 0. So we say, are these pointing to a different character? Nope, they're pointing to the same character, meaning pointer is pointing at an A and I is pointing at an A. So we move I up. Now, are they the same character? Yep, still the same. Move I up. Are they pointing to the same character? Yep, still are. Move I up. Are they pointing to the same character? No, for the first time, they're not. I is pointing at B and pointer is pointing at A. So how do we know how many A's we're looking at? Well, I is at 3 and pointer is at 0. So I, which is 3, minus pointer, which is 0, equals 3. And guess what? That is how many A's we have. So then we move pointer up to here. Well, I think I missed that in my code too. And then I would go. And when it's off the board, then we do the same thing. We say, okay, I is up here now at 7 and pointer is at 4. 7 minus 4 is 3. So the difference between I and pointer gives us the count of the sequential characters that we're looking at. Cool. It looks like you got that, Daniela. Great. That makes me think that I didn't do something here, which is another step, which is move pointer to I. Now, again, if an interviewer is nice, they're going to help you with stuff like that. Oh, Jordan, it looks like you're using a 2-pointer, but you forgot to move your pointer. Oh, yep, I totally did. Let me add that. If they're nice, but they just don't see it, which is very possible, then maybe they'll suggest it later. But regardless, it's no, like, don't get flustered. Don't feel bad. It's like, oh yeah, it's a lot of things to remember. We're figuring it out as we go. That's part of the process, is figuring it out as we go. It's not reasonable to think we're going to nail everything perfect right from the beginning and not have to go back and fix anything. So you've already seen this problem. I had to go back and do this. I had to go back and do this. And I think I had one other thing, right, that I missed. I forget, but whatever. As far as I'm concerned, that's acceptable and normal. Okay. Convert them into a string. So what does that look like? It looks like an array with an integer and a character. And it needs to turn out something that looks like this plus comma plus this, like so. Seems like, okay, pretty good candidate for a helper function. Same things going in, the same things coming out. Maybe we can do this pretty easily here. I don't know. I could go either way. Let's do it here for sake of time. But I would probably raise that to an interviewer. I could do a helper function here. It might be best. I might abstract this out anyways later. Compressed array at I equals. And we're going to go back to the same type of string. We're going to say, okay, we know we're going to have opening and closing brackets. And then in the middle here, I'm going to have something like this is, you know what? Let's set up a variable. We'll call this let tuple equals compressed array at I. And now here I can say tuple at 0, comma. Can I just put the whole thing to a string inside of here? I think I can. I think I can just do with this. I can do exactly what we did here. So I could just do something like tuple dot to string. Yeah. Okay. Yeah, worth a try. So we've already got this console log here. I think we're just going to go ahead and run that and see how we're looking. Okay, let's take a look. That looks better. Is that the same as instructions? This is a string. No, because we still have to have the quotes. Why do we need to use string interpolation to convert to string for a valid response? We need ours to, I'm not sure I totally understand your question, but we need ours to look like this. And when I look at ours right now, it looks like this. It does not look the same as this. It looks mostly like this, right? We've got an array, we've got the array inside, we've got this, but we don't have double quotes around each of these letters here. We also have a problem that our A is not moving up, I see, from this here. Let's fix this now. Pointer equals I. Let's see if that works it. Makes it work. Take a look again. Now I have A, B, and C. So that's an improvement. That's one thing we need to fix. But we need to wrap A and B and C in quotes. Okay, it's a little bit tricky, but I suppose that comes with the territory here. So if I go back, okay, what if this is not going to work? Tuple to string, maybe not. How about tuple at 0? My bad. At 0, comma, backslash quotes, just 1, then tuple at 1, backslash quotes. Clean up here. Let's think about this for a second. Here's our number. This needs to close. So I messed that up. Okay, that looks good. Then a comma. Then going back here to the instructions, no space. So I don't have any space here. Then double quotes. Then the character itself okay? Then double quotes again, then the array. Again, the more we do here, the more it's like, yeah, we should definitely make this a helper function. And I probably point that out to the interviewer. I'm kind of deep into this line now, but I'm thinking more and more we need to make this a helper function to clean up our code. Okay, let's check it again. Now we're cooking. That looks just like theirs. 1A, 1B, 1C, where A, B, and C are wrapped in quotes. We come back here. And again, they don't have exactly the same example here, but yes, now ours looks like theirs does. So now I'm feeling pretty good about that. I'm going to go ahead and delete this line that's not pseudocode. And move this one down since it represents this. Nope, wrong one. What did I do here? That needs to come up. Okay, now this needs to come up. Okay, fine, that'll work. Cool. For this, oh, I don't know how I messed that up so bad. This looks terrible now. Did I delete something here? Got my code all messed up. Here's this. This closes here. That's fine. This all needs to be pulled back to here. Then we do that. Yep, that looks good. We can get rid of this now. I'm pretty comfortable with that. And we'll test it again. Okay, all our tests are passing. We've got one more test to go in this case here. It's this one right here. 3 A's should give us 3 A's. So let's give that a try. I'm going to go ahead and copy this test line, paste it in here. And we go A, and A. Test that. Great, still passing. Okay, we move on. Now we've got, it's like, we could change this to say 10 or less characters, and then all of these could fit in there. Seems good to me, but then, yeah, because it seems like anything. Yeah, I think anything, I think that's fine. Actually, I think that's correct. Handles a string of 10 or less characters. I'm going to tell the person, it seems to me anything 10 or less is always going to return the same string. I'm not 100% sure of that yet, but like, even if I add CCC here, or I make it 9 A's, or I do A, B, C, D, E, F, G for 10 letters, whatever that is, it looks like they're always going to return the same string. So all those cases kind of go together for me. I'm going to change my message here, and I'm going to add another test, and I'm going to put in here A, B, B, B. So here is my input, and here is my output, and let me run that. Great, that looks good. Ready to move to our next test case. And that's going to be 10 A's. This is the case that we gave as an example of something that is the same one way or the other. Let's see if this is working correctly. Okay, that's not working. Instead, we got this. Let's count the characters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 here and 10 here. I read the logic and it said, unless it's shorter, return this. So they're tied, which means I should return this. That means we need to go back to our logic and check. Is the compressed string dot length less than or equal to? Okay, I actually only want it to be less to. That was my bad. Return the shorter of compressed array as a string and string. So we'll say this, return shorter of compressed string or string. Return compressed string if it is shorter than string, otherwise string. And again, I don't have a problem refining my pseudocode like that. In fact, I think it's admirable if you do that. You say, this line's not that clear. In fact, it's only been 20 minutes and I'm reading it back, whatever it's been. So I'm just going to go ahead and change that. And now we'll go ahead and test that. Hey, we're looking good. Okay, we're ready for a new case. And this we will say, I'm just going to copy out this if statement. Save myself some time here. I delete all of these, oops, except for one. I'll keep one of those. There we go. Now we need to come up with a new message. So here we'll say it handles a string of any one character of 11 or longer. And here we pass in our 11 A's and we return our truncated string here. Let's see if that works. We'll go ahead and test that. And it didn't work. The only reason it didn't work, though, I think, is because in my tests, I used single quotes and here I used double quotes. So let's change. I think this is a fair case to change our test and put our single quotes on the outside like they did. This is just something I should have done when I wrote my tests. But I don't think it's a big deal. Do that and run that again. Okay, it still didn't work. Let's see what's going on here. Expected this 11 A instead got this. Okay, give me 1 second. I need to open the door. I'll be right back. All right. So what's going on here? We just got to dig in and see. They look similar. Let's try deep equals. Deep equals will help us when, for example, like two arrays don't come out the same, but they should be the same. But that still doesn't work. Somebody see differences here that I don't see in my eyes? I think you're missing this. Oh yeah, we totally skipped that. I missed that over here in the instructions, right? Oh, but they don't. Oh, my test is wrong. That's the problem. This is a testing problem. It needs to be a comma there. It needs to be a comma here. Thank you, Daniela, for calling that out. And now we're good. Now I think I don't even need deep equals. It's a string. It should work fine without it. There we go. Great. Let's do the same thing here. We don't have this in our examples, but if we had the time, I'd say it'd be great to do another one of these. And we just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 B's, and we should get that. Boom, we're looking good. Time for a new case. We're almost there. We're almost there for the first half of the problem, right? I'll leave the decompression for you guys to do on your own. Here we say, okay, it handles a string of more than 11, more than 10 characters of any length. So we've got quite a bit that we're going to fit in here, but we'll start with our examples here. We've done this. We've only got 2 examples up here that we want to pass in here. So the first one is, my bad here. There we go. See if I can paste that in. And again, I'm just going to copy straight up the solution. Now this solution I copied from the instructions. So my single quotes and double quotes are correct. Go ahead and test that. Okay, something is wrong. Expected this, instead got this. Okay, why is that? Let's count the length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is longer. Did I mess that one up? Where is this example coming from? Coming from up here. And generates an array that sums, yes. The compressed version is this. Okay, this version, I guess this is longer. So I erroneously copied this when I shouldn't have. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's way longer. So my answer is wrong here, and it should have been this. I notice this kind of confusing, right? It gives us this example and it says this is how you compress it, but it doesn't say this would be the correct answer because this is longer than this here. So that was my bad in making incorrect assumption. Feel free again to jump in the chat if you think I'm wrong there. It looks like our answer should actually be this, which is good in that our code is working and bad in that I made a mistake. Oh, also we need to delete this case. So here I will paste in This is a question you'd skip. Yeah, I mean, you got to practice with questions like this that have, you're going to get all kinds of interviewers. And if this is confusing, you're going to get some real confusing interviewers as you go. Why didn't we use the regular expression approach? Which method would you use to add the? So we could use regular expressions here. It would rely on a knowledge of regular expressions for one thing. And if you know them and you want to go that way, you should. I love regular expressions. Also, I think it's much more instructive to solve it like this, which is why I'm doing that here. And I think this approach is much more applicable to a wider variety of problems than regular expressions. But if your inclination is to solve this as a regular expression, still get points. Still good with me. Still be good with an interviewer. It's also not really any more efficient to solve it with regular expression, so it's just a different approach, though a good one. Okay, here is this one here, and my bad, I should have copied this first. Let's copy that out. Hopefully we finally get to one that actually needs to be compressed here. We'll take that and put that on the other side here. Yes. Good, we're looking good. Okay, that's all of our examples here. And I think we took everything we could from here, didn't we? Or is there one more? Is this the same? This is 26A, 26A, 18A. Yeah, it's the same. Great. So I would say now we need to write maybe 2 more examples. I'm going to do that. And then like I said, I'll leave the rest for you guys, the last function to complete. So I mean, the examples get really long, right? If I delete this and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I say I have 15 C's. And if I go over here and I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's 23 P's. And with that, let's go ahead and test it. Looking good. All right, let's get a case that's like this, that would also fit under this rubric, which would be like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now, this should be shorter than the long string version of this. So this should be equal to itself, even though it's a long string. You'll notice, though, it does fall under this. It handles a string of more than 10 characters. Handles a string of more than 10 characters. We don't need of any length here. I don't know what I was thinking of, just a more than 10 characters. And we'll test that. And we're passing there too. Okay, we got a couple more cases to test here, right? Like we want to look at uppercase letters and lowercase letters and make sure that we don't have any problems there. But we're pretty good here. I think we are likely handling all the cases for this first half. And now I'll leave it to you then to work on the decompression side of this problem, to take in a string or one of these arrays and fix it up, and then you get the points. Thank you for hanging out. Maybe I should make this class 2 hours. I see that talk a little bit and then get through an easy problem, and a hard problem takes about 2 hours. So it's great though. I think we did some nice work here. I think there's lots that can be improved. Like we talked about breaking some of these things into helper functions. And it's great practice. This is where you want to be. You don't want to be skipping questions like this. Just gonna, it's just gonna challenge you and make sure that you know everything, pay attention to details, pull some details out of the sample test, pull some details out of the problem description, pull some details out of inference from other things that you see. But it's all important. Any questions today before we end?